Hi all, just thought I'd share this one with you. I've had a go at making my own Bluetooth speakers, and so I bought a module off eBay, and there it is, a bit difficult to solder to, and I've hooked it up to an audio amp, which is a TDA-2822, which is a dual power amp. As you can see, I've got some switches there to shuffle the songs, pause, play and change the volume. And yeah, I've just hooked it up to a couple of old surround sound speakers, but actually it sounds pretty awesome. So I found it very difficult to get any information about this module. It's a XS-3868 Bluetooth stereo audio module, which, as you can see in the centre of there, carries a chip which is an OVC3860. Like I say, it's a bit of a tricky module to work with because the connections are at 0.5, not 0.5 inch, but normal ICs are at 0.1 pitch. This is at half of that pitch, so it's very difficult to do. I had to actually design a layout for that on the back of the board there, as you can see, to fit it. Did make a bit of a mistake though. I should have really put it so I soldered that onto the back, but anyway. As I said, it was actually very difficult to get any information on these modules, but I came across this article, look, eevblog.com, and there was a few people who'd written stuff, but I found this member's contribution particularly useful, and really I would have been stuck because this is a version 2 module I've used, but luckily this person here had already fathomed this out, and there's two little PNG files there. If I just quickly open them up, very useful. It shows you the pinouts, etc. of the chip, which I wouldn't have been able to do this project without that. So thank you to those people. I had a bit of a play around with this. What have we got on here? Well, the module itself runs off between 3.6 volts and 4.2 volts. To get that, I'm running mine off 9 volts. I mean, this module actually does have all the circuitry to charge a lithium polymer battery, but I haven't bothered with that at the moment. I've just made it. I'm trying to make it for people to construct in kit form. Now, I figured if we just work it off ordinary dry cells, it's less complicated. So at this end here, I've got a little 5 volt regulator. To knock the voltage down even further, I've got a diode there which gives a bit of a volt drop. And so I've found out with that stabilizer, off about a 9 volt supply you get about 4.9 volts coming out. The drop across the diode takes it down to a safe level for this module here. The module itself has got its own 1.8 volt power supply, which is one of those ICs on the module, and that's what I'm actually using to power up these buttons and pull these high. It's better if you do that. I had a couple of problems with it in terms of it was very noisy. When I first hooked it up, yeah, the sound came out great, but there was a lot of background noise. Originally I'd interfaced the audio outs into the amplifier using some resistors. I thought, well, I'll put a bit of a load resistor there to develop the voltage across. Turns out I didn't need them, so I've actually put some capacitors in there. So there's some coupling capacitors from the module to the amplifier. But like I said, there was some real high-pitched sound on there, almost a bit like you could hear on an FM radio when it's receiving a stereo signal, but not very strong, you know, like the multiplexing noise. So instead of having resistors to ground, I've actually put some 10 microfarad capacitors to ground, and that seems to have got rid of a lot of the high-frequency noise. And it hasn't really disrupted the quality of the sound. Now, I'm actually quite pleased with the quality of the sound off this. So I'm running this off some 9 volt battery pack. Don't use a PP3 because it just hasn't got enough umpty to power the amplifier and the module at the same time. Typically when it's quiet, the module uses around about 50 milliamps. When it's belting out the music through that TDA-2822, you can get up to 500 milliamps on full pop. These are 4-ohm speakers, by the way, I'm using. I'm just going to switch it on. So I've just hooked it up with some dry cells. Unfortunately, the battery holder I'm using, it's a bit knackered. It's out of some 1960s walkie-talkies, and it's a bit corroded. So if I switch it on, you can see that it makes that sound, or you can hear it makes that sound. The LED starts blinking there. I'll go to my iPad here and I'll just turn on the Bluetooth, and let's go when the menu appears. Quite an old iPad. Turn the Bluetooth on and then it should find it. There it is. Now there is a little bit of noise, but I find that there's noise even with commercial Bluetooth speakers. The pairing, by the way, by default is 0000. I've not found a way to alter that. Right, so we're connected. What I'm going to do now is I'll just go to my music and I'll play a bit of sound for you. Now there's a bit of a low frequency hum there. Again, the shuttle buttons work, so if I press this button here, that will take me to the next track. And got the pause play button, the reverse button. You've got hardware volume, so you can turn the volume right up. Also control the volume from your iPad. Interestingly enough, those buttons don't seem to make the volume on the iPad go up and down. I've also found that when you use this to make telephone calls, it works actually quite well with telephone calls. You see there's a microphone on there I've got rigged up, and you use the volume controls to adjust the volume of the call. Pretty clear actually, the sound from the telephone calls pretty good. So. But there is a little bit of a low-pitched hum in the background there. I don't know if you can hear it. One of the problems is there was a lot of high-pitched sound on there as well, especially when you pause the music like I've just done there. You would still hear a lot of noise, and I don't know whether that's because the radio, and that's the antenna there, look, is interfering with the audio stage. Maybe I've planned out the circuit board a bit wrong. But once it's running, you've got it running at a reasonable volume. The sound quality is really quite nice, especially listening to something like piano music like I'm doing now. If I go and find something a bit more modern, let's have a look. Find a new album. No, I don't like any of them. Ain't no Happy from Despicable Me.
Crazy what I'm about to say. Sunshine, she's here, you can take a break. I'm a hot air balloon that could go to space. With the air, like I don't care, baby, by the way. Give me all you got, don't hold it back.
Yeah, one of the things what does happen is if you actually turn this off, it doesn't seem to remember what it's been connected to, so you have to actually go on your Bluetooth settings and connect every time. I'm actually quite pleased with that, so I might just have a call with the wife in the other room. She'll phone me, I'll see if I can use it to make a call. Okay, so I've switched to the iPad now to film this, so it'll be a bit grainy. I'm going to use my iPhone to phone my son, so I'm just going to give him a quick ring, but it's going to happen through the Bluetooth speaker. It'll be a bit loud, so that's where this volume control comes in. I'm just going to turn it down to a moderate level.
Yeah?
You alright, son? Can you hear us?
Yeah, I can hear you.
Ah, very good. Coming through clear?
Pardon?
Coming through nice and clear?
Yeah, it is, yeah.
Okay, mate. Have a good night anyway. I'll see you later. Night night.
Alright, night then.
So there you go, you can use it to make and receive phone calls as well as listening to you. So as you can see, it is quite possible to build yourself a Bluetooth speaker system. I think that module cost me about £2.50 off eBay, and the circuit board I had to play with at work because I'm designing this for work, believe it or not. Anyway, yeah, tested the range on it as well. Some people reported not very good range off this module, but I've actually found I've got about 10 or 11 metres off it. One of the things I did do when I designed this as well is I made sure that I left the copper out of the way of the aerial on the module, so maybe that's helped, I don't know. Anyway, thanks for watching. Cheers.